Hit in the hand. Whoa.
What was that?
Uh-oh, don't tell me the video's gone.
Nope, it's still going. It better not. Okay, so now what do we do? What do we do? Equal that to the derivative. So 6x minus 5, right? What does it equal? 4. Now where would this get ugly? If the derivative was hard or if the numbers were evil. But you could still do it. So 6x is going to equal 9, so x equals. Now, you need to be careful. Especially if this is a quadratic, you may get more than one answer. Make sure your answer is on the interval and not an endpoint. Okay? Answers must be on the interval and not an endpoint. Well, I guess you could graph it and see on a calculator. It can't be an endpoint because of the definition. Okay? If we go back to definition, it says that the answer must be on the open interval because we can't take a derivative at an endpoint. Okay? So we cannot use an endpoint for an answer. AP loves to do that. It's multiple choice, and the first answer they give you is a point. They'll also give you some that aren't even in the interval. Cross them out. And then the ones that are not. Alright, are we ready to move on? We have MT?
Yeah.
Yeah?
How would you know if it was the interval, like if you're just with the interval?
Well, your endpoint, you're 3. So if you're looking at multiple choice, and one of your answers is 0 on your multiple choice, you can immediately cross it out, because an endpoint cannot be a solution to MT. Okay, last theorem for today, and this one's actually very, very easy because it's according to MT. It is called Rolle's theorem. No, it's a name. Okay, Rolle's theorem has an extra condition. F of x, so f of x is continuous on interval a to b, close, and differentiable on the open interval a to b. And A equals f of b. Roll. First, I have to draw it because we always draw a graph. Then they tell me about this function. It's continuous. It's differential, so no corner, vertical tangents, no holes. And f of a is the same as f of b. Did they tell us what was going on in between? No. Just continuous. What would the derivative have to equal at some point on that interval? 0. Because at some point on an interval, you have to be flat. Could it happen more than once? Yes. But it has to happen at least once. They love to test Rolle's theorem in multiple choice because they'll give you that it's continuous and differentiable but never tell them you're equal. And then they say, which of the following must be true? But they never told you they were equal. So you have to eliminate Rolle's. Rolle's can't be true unless we know that they're the same. Okay? So, ready for example? Okay. Yeah, that's it.
So this is basically MBT except the line is horizontal?
Exactly. And we should write on the open interval A to B. Okay? Because it's the same thing, it's just on an open interval. Okay, we ready for an example? Now what can make this harder? Harder derivatives, harder numbers. But the process is always the same. So, f of x equals x squared minus 1 on the interval -2 to 2. Find the c guaranteed by rolls. Now, more often what I will ask you is, would rolls work in this situation? I love to do that. Okay, but we're going to actually find the c. So the first thing we always have to do on these is make sure that rolls even applies. Okay, so is it a continuous function? Yeah, polynomial, quadrat. Is it differentiable? Any sharp corners?
No.
No. Is f of a equal to f of b?
Yeah.
Yeah, because that's 3 equals 3.
Yeah.
So rolls applies. We're good? Okay. So what do I need to do? Take the derivative. And what do I set it equal to? Yes, sir.
Can you take like a step back for a second? You
Yep.
said, how would you figure out if rolls would work or not?
Okay. The 3 things have to be true. It has to be continuous,
Okay.
which it is. It's a parabola. It has to be differentiable, which it is because it's a parabola. There's no sharp corners, no tangents, nothing weird going on. And f of a has to equal f of b.
And how do you know f of a equals f?
This is a and this is b, so I just plugged them in. F of -2 is equal to f of 2,
Oh, gotcha.
so therefore rolls apply.
So if it was like x cubed minus 1, that would not apply.
Correct. Okay, so which x value on the interval is the place where we have a horizontal tangent? At 0. Which I kind of knew because that graph looks like that. Where is it at? At 0. Okay, now when you do your homework, you're going to have some ugly functions, but the processes are all the same. Okay, it's on 2 separate pages, one for the absolute extrema and one for rolls and MVT. Okay, the next class we're going to focus on how to find relative extrema and how to draw graphs from a derivative. Okay? We got it?
Yeah.
Okay.